Hello and welcome to the Grand Forks Skywarn Spotter Training online session. My name is Jim Kaiser and I'm sitting here with
Jacob Spender. I'm a forecaster here at the Grand Forks office.
and I'm the warning coordination meteorologist at the Grand Forks Weather Service office. Thanks for joining us, whether you're at work or at home. We appreciate it. Why are we here? Well, as we slide forward, we're here because severe weather happens across our region. And this is a crazy image with lots of colors showing all the different tornado touchdowns from 1950 to 2021. The different colors represent the intensities of those tornado touchdowns or the strength of those storms. We can see pretty much anywhere has seen some tornado activity in the last 50 years, and we're guaranteed to have more tornado activity. So we're here because weather can cause hazardous, damaging property and or life concerns. So that's why we're here, and that's why we're hosting this training. Cleaning the map up a little bit, these are the tornado tracks that are considered significant tornadoes or violent tornadoes. And you can see they happen as far north as the Canadian border. So it isn't just a Southern Valley occurrence. And these are the ones that produce the most damage, that are the danger to life, and we want people seeking shelter. We want people being aware on our tornado days because we don't want the worst case scenario to happen and the people being unaware, caught off guard. They don't have a plan in place. We want them listening to our information. We want them seeking shelter when they need to seek shelter. And we can't really do that without information from people that are on the ground in those communities. We push out a warning, but it means so much more when we can say spotter reported, law enforcement reported a tornado on the ground. In an impactful situation, people will respond much more quickly when it's a reported tornado. So we need your eyes on the ground to help convey that information, the seriousness of the event. So the agenda of this hour-long little training session, we're going to talk about the role of the spotter. We're going to talk about identifying the risk. We're going to talk about our products, our watches, our warnings, our statements, and we're going to go into a guide on spotting. It's going to be quick, it's going to be brief, but we'll give some examples. And then how do you report that severe weather? What's the best way to get that information when that weather is occurring into our office so that the warning meteorologist and the person relaying that information to them have that most immediate up-to-date information. So the role of a spotter, what do we need you to do and how do we need you to do it? We need communication. That's why we're having this. That's what we're doing here, right? Our meteorologists rely on 3 different things to issue a warning, right? They want to see that radar information when they make that warning decision. And it's based on those atmospheric conditions. So is the atmosphere capable of producing a tornado? Do we see the ingredients that are needed for that tornado to develop that the radar is showing us? And then severe weather reports, right? Not always are we in the best position with our radar information to make that decision. So if we get a report of a tornado on the ground, obviously and there is no warning, we're now issuing a warning. So it takes 1 and or 3 to actually trigger a warning. Communication and relaying those reports is crucial to our warning process. So why is that spotter perspective important? Well, when we scan the skies with our radars, we're not seeing that lowest layer that's on the ground. We can see that storm, and we can see 3,000, 5,000, 8,000, 9,000, 12, 15,000 feet into the sky, right? But we're not seeing that lower 2,000 feet or 4,000 feet, depending on how far a person is from a radar location. So the spotter eyes play a vital role in helping us meteorologists make a decision on whether we're issuing a warning or not. Is there a wall cloud? Is it rotating rapidly? Is there a funnel cloud out of the wall cloud? Is there a tornado that's, maybe not all the way on the ground with a funnel cloud, but you'd see that dust bowl and that swirl on the ground already with that circulation of air spinning up on the ground, relaying those bits of information to our warning meteorologists help us make those crucial decisions where minutes do matter. So that's why we're here, and that's why we appreciate your information and relaying that information to us. So what's the advantage of being a spotter? You see what's on the ground, right? You see what's occurring versus what we see. We see those reds and curls of radar reflectivity, or we see the red-green in our velocity radar imagery, right? But you see the inflow on the right side of that storm there on that tornado. You see that wall cloud rapidly rotating. You see the funnel starting to stretch down and to reach into contact, and then the tornado. And then you see when it dissipates also, right? Like that's also great information for us to know that, hey, it's no longer actively damaging or the potential for damage to be occurring. You can relay that information, and we see what we see on the radar.
So why we need your report itself. So getting any kind of severe weather and especially tornado reports, it's crucial to our warning system itself. So we need to stay in the loop. So we need reports from people. We need that open communication with everyone because that helps us with that decision-making process. So like I said, if the NWS isn't in the loop, we can't do the certain dissemination of methods that occur that you can see below. So that's the wireless emergency alert system that you get on your phone, the automatic EAS activation on radio systems, the crawl that kind of cuts in on the television during the news segments or anything, and alert activations on any of the favorite weather apps that you may own or your smart device. And also with different alert systems based on counties, if you have a NOAA weather radio, which Jim, we always recommend that for people. And then alerts for any counties downstream of any kind of storm. So we have that tornado reported by someone that is a trained weather spotter that helps alert that person that could be in Bemidji and the warnings for Foston. They know they're in the loop of that potential that's coming from that storm downstream, or upstream, I should say.
Right. So when we do issue that warning, all of these things get activated or notified. So all of this, when the warning leaves our building, it activates all 6, 7 of those things, as long as you're in that alert area. And so if the warning doesn't get issued because the radar signature isn't there, we're not getting any reports, these systems that are in place to protect people, they don't get activated, and so there is no notification. So that's why it's really important to communicate and relay the information from the spotter to the office.
Exactly. We're all in this together in these kind of situations.
So how do we identify the risk of the storm? Or how do we communicate our risk days from a severe weather perspective to you?
Yeah, so we work in conjunction with different areas, the Storm Prediction Center, the Weather Prediction Center. For severe weather, we work hand in hand with the Storm Prediction Center and they do these convective outlooks that are out to 7 days. So as you can see up there, it ranges from 1 to 5, as well as a general thunderstorm risk. So today, which is April 22nd, we have a general thunderstorm risk across the area. So we're not looking at any kind of severe weather for today, but there could be a marginal or a slight or enhanced. Those are the lower categories, and they're kind of based on the potential for any kind of severe weather. So as we're looking at marginal, these isolated severe thunderstorms are possible. And then as we get up into those brighter colors of enhanced, moderate, or high, that is expected to be scattered to numerous severe weather events, and we're looking at more significant severe weather potential. That's looking at that potential of EF2 or higher ratings, hail of 2 inches or greater, or 75 mile per hour winds or greater. So those are the higher risk days. Now, with this is easily accessible on sbc.noaa.gov, and like I said, these outlooks are out there for days 1 through 7. So here's a great example. This is back in May 12th of 2022. This is the SPC outlook that we worked with for the severe weather potential. Now you can see there we had a moderate risk in the Fargo-Moorhead area down through Fergus Falls and into Grant County, and then a slight risk toward the north. So that's the information that was provided to us and to the general public and to our core partners prior to the actual event starting. So when you see this kind of map, it kind of gives you a heads up, hey, today we're looking at that severe weather risk. And the outcome is what we see on the right-hand side. This is why reports are very vital. All those dots that you see, the red, the blue, the kind of blackish color, and green, those are all the severe weather reports that came in to the agency through Twitter or through X, through Facebook, through phone calls, through emails, everything. So you can see that those reports of tornadoes and high wind from this MCS or derecho event came into our offices. So a total of 484 reports we got from this day. So here are different ways that you can take a look at identifying the risk for severe weather. Now, weather.gov/FGF is the homepage for the Grand Forks Weather Service for our main little area. Now, you can find this through a Decision Support Service packet, DSS packet. That's going to be on the upper right-hand side that you can kind of see there. It'll identify the risk at the top too. Severe thunderstorms possible from late this afternoon through late tonight. Now we also do have a monitor system at the top as well, where you can see Jim's kind of putting the mouse up there. So you can see up there, we'll put up the severe weather potential, we'll put radar, we'll put all that kind of stuff so you can kind of stay in the loop. Now we also do issue some weather stories for severe weather events too, which will help you identify the different types of impacts. Is hail the main impact today? Or is it wind? Or is it both? Or is it heavy rainfall, tornadoes, hail, wind, all of it together? We'll kind of put that there and share that out to different social media outlets. You can also get your hourly forecast outlook, as well as the hazardous weather outlook, and also the area forecast discussion, which is going to give you a very detailed look and the upfront key messages for the day. So you're going to kind of look at the very scientific side of it when it comes to the risks that we're seeing for the day. And we also have our watches and warnings map, which you kind of see right in the middle. And yeah, that one's a fun one. You have a tornado watch, you have flash flooding, you have blizzards out into the west. So many different impacts can happen all at the same time, especially in the northern plains of the United States. So now we're going to move on to our watches, warnings, and statements that the National Weather Service does have.
All right, so severe weather watches, right? Severe thunderstorm watch that come in hopefully hours ahead of time, but not always. So issued up to 6 hours in advance for when conditions are favorable for severe weather. That is winds greater than 58 miles an hour. That is hail an inch or larger in diameter. There is a subset category of watches that are called particularly dangerous situations. So those are PDS watches, and about 10% of the watches that the country is issued for the country are PDS watches. Our watch is your get ready. It's a heads up that, hey, we're expecting severe weather. It's expected to occur, in the next 2 to 3 hours. Storms should start forming. We post this to social media. This is the graphic on the right that is similar to what we post. It shows, the area that's affected. It shows how long it's valid, and then the main threat information is there. Besides, let's go back. We're on slide. Besides the severe thunderstorm watch, it can also be a tornado watch, right? It isn't just severe thunderstorm watches. We also issue tornado watches and flash flood watches. So those are the three different types of convective watches that we issue. This one on the right is just an example of a severe thunderstorm watch. When you break that severe thunderstorm watch up in the text products, this is not a severe thunderstorm watch text. Sorry. This is a special weather statement. So this is a text product for a single storm that is sub-severe. It's not producing severe weather that we know of or that we expect. We'll often push out these for wind gusts that are up to, say, 50 miles an hour or around 50 miles an hour. Hail that's smaller than an inch. Sometimes it'll be a particularly strong storm that has a lot of lightning, but no other severe indicators. So we'll push out this special weather statement. It's polygon based, so that means it's just based on the size of a storm. It's not based on county level occurrences. It's the same kind of format as our warning, where we talk about where the strong storm is. We talk about what the hazard is, the source, if it's been a report or if it's radar indicated, and then what are the impacts. The severe thunderstorm warning is very similar to that previous product that I was talking about, except that now the threats are severe in nature. So you got hail greater than 58 miles an hour or hail larger than a quarter. Anyone in the polygon or anyone in the shaded area is at risk for severe weather. It's imminent and or occurring. And now it's the time that we would love for you to report back to us what you're observing, right? And so as the storm's moving towards you or at you, you had winds estimated at 68 or 65 to 70 miles an hour, or you've had hail. Some of it's an inch in size, some of it's a golf ball size, right? So we want to know the largest hailstone. We'd like to know how long it hailed at your location, those types of things.
Any damage to trees or infrastructure or anything like that is also very important.
Yep, damage. So wind is really the hardest thing to kind of estimate how strong those winds were. So a damage indicator would be, a healthy branch got broken off that's the size of your wrist or larger. That's usually a good indication of winds 60 miles an hour or better. So what's next? So instead of just a severe thunderstorm warning, we have tornado warnings. Tornadoes on this example, this is a tornado that was observed. If you look in the threat information box, you can see that this tornado was observed. So it was reported by a spotter or sheriff, law enforcement, somebody observed this tornado with a warning time valid until 1 a.m. So they saw this tornado even though it's nighttime and it's dark, but still we're able to report that. So this type of information is vital. It gets people's attention, right? So instead of a radar indicated an observed tornado warning at midnight to 1 a.m., this is a big deal. So important information that gets relayed.
Those tornadoes in the nighttime are even more deadly and more dangerous. So getting that observed tag in there from a spotter or even an NWS employee that lives in the area or anyone, law enforcement, when we get that tag in there and you see it pop up on your phone, it heightens your senses to, hey, I need to take shelter now. I need to get into the lower structure of my home. I need to find a tornado safe area. So especially in those nighttime scenarios. So that observer probably could have seen it with the lightning in the background, said, okay, I see it. I'm going into the basement.
Yep. The warning text of our warnings looks like this. It shows that we've issued it. It shows how long it's valid for, where the storm center was at the issuance time at 12:23 a.m. And then it talks about what that hazard is. So we got a damaging tornado, quarter-size hails with this storm. Source, the radar confirmed the tornado. So the radar saw the debris signature or the debris that this tornado was kicking up. And we can see that on those storms that are close enough to the radar where the lowest level is able to scan the debris that the storm is kicking up or lofting into the sky. We see those bits of crops or leaves and trees and shingles and anything that can get lofted and lifted 1,000 feet up in the air. We can see that, and the radar says, oh, this isn't ice, this isn't water droplets, it's something different. And so we can correlate what it sees and realize that, oh, hey, these aren't normal meteorological signatures that are bouncing back off that reflectivity beam. They are weirdly shaped objects that aren't raindrops or snowflakes or ice crystals. So that's an interesting piece of science that the radar allows us to use and do. It talks about the impact. So there's flying debris with this, and anybody outside or without shelter will be in a bad spot, right? Like mobile homes could be damaged, destroyed. Damage to roofs, windows, and vehicles will occur. Tree damage is likely. And then it gives a path of when the storm will be around the next town or so. And then at the bottom, it talks about our tags. So this tornado was observed, and then the max hail size is 1 inch.
So a great reference that we like to use here in the Weather Service with our partners and everything is the watch and warning taco reference. So we have all the ingredients necessary for severe weather to develop in this area ahead of time. 3 hours ahead of time, the atmosphere is conducive for severe weather. So think of it in terms of, hey, dinner tonight, I'm making tacos. I have all the ingredients. I have the guac, I have the shells, I have the ground beef, all of that. Now, making it together, and we have the taco itself. It's fully assembled. That's the warning. It's imminent or occurring. It's imminent. You're going to eat that taco. So, in this reference, we have all the ingredients for severe weather ahead of time. And then when we have that severe weather unfolding and you get that severe thunderstorm warning, that tornado warning, it is imminent or occurring. You're about to eat that taco. You can think of it in the Northern Plains reference of a hot dish, or I like to call it a casserole because I'm from Wisconsin. So you can think of all the ingredients for that hot dish, and then, hey, it's right in front of you. You're about to eat it. That's your warning. That's your hot dish warning right there. Or casserole is how I like to say it. I'm going to throw that out there one more time.
All right, how do you receive the warning, right? So there are lots of different ways. Your phone will alert you if you haven't shut off your WIA alerts. The TV, the radio, internet, mobile apps, NOAA weather radio, a county warning system Cast Clay Alerts, Code Red, Event Bridge, Everbridge, X, mobile widgets. All of those are different ways to get the warning.
So now we're going to move on to your guide to actual storm spotting. So what you're kind of looking for, the ingredients, all of that. So for a storm to develop, a thunderstorm across the area, we need 4 ingredients. We need moisture, we need lift, we need instability, and we also need wind shear to actually develop that thunderstorm.
Right. So with those ingredients, you can see we kind of have at this first stage on the far left screen, the towering cumulus stage. So that's where we've got lift and moisture, and we've developed this cloud, and this cloud starts to rise and keeps rising, and then you see the dashed line there. That's our freezing line. So it rises above the freezing line, creates hail and ice, right? Like, so that's the beginning stages of the developing cumulus cloud, or the cumulonimbus. And then to the middle section, we get the mature stage, where we have that cloud that's reached the top of the troposphere, where all of our weather happens. The layer of the sky that's around the Earth is with the weather is the troposphere. So it reaches the top of that troposphere, and it's got an upward motion that occurs, and then it's growing hail, and it's making big raindrops and everything as it moves up above the freezing line, and then it starts to fall because gravity eventually will win and pull that hail down through, and as we're balanced, we have that upward motion and the downward motion occurring at the same time. We're at that mature stage where the storm is like its strongest that it could be.
It's working in unison with each other.
Yep, they're in unison with each other. And then on the far right, where it's all just downward motion, downdraft, we call that the dissipating stage, where there is no more growth and it's decaying or dying.
The downdraft is winning. Gravity is winning fully in that situation. So there's 2 types of main thunderstorm complexes that we kind of look at when it comes to weather. So we have squall lines, as you see on the left-hand side, going through my home state of Wisconsin. And then on the right-hand side, we have supercells, more finite. They're smaller compared to the actual larger linear or squall lines, like on the left-hand side. So on the right-hand side, you kind of see that hook in that storm right there. That's a really good indicator of a good, strong supercell thunderstorm.
Yeah, and the scale is what really jumps out at me on this map, right? So this is the county size, where it's affecting a county or portions of a county at one instance of time, and then here we're affecting portions of many states at one instance of time. So the squall line it produces a much larger area of severe weather than, say, the supercell, but the supercell kind of gets all the attention because it's got the big tornado wrapped up here, and causes that heightened risk of extremely violent damage, versus the squall line, which has kind of those pockets of potential for wind, some hail and heavy rain, whereas this guy's got 4-inch hail maybe in it, and possible big tornado. And so those are kind of the 2 different real types and regimes that we're dealing with across our severe weather envelope.
Yeah, so here's a good example of a squall line that's actually going through our county warning area, or eastern North Dakota and northwestern Minnesota. So multiple storms are organized in that line itself. This is going to give you that widespread wind damage. So as Jim said before, with that, it's affecting a larger area. So it's affecting, as you saw in that video, that's affecting all the way from South Dakota all the way to the Canadian border itself. So like I said, widespread wind damage potential with this. You can also get isolated tornado potential and isolated large hail. Now, there's many different types of squall lines, which we have here are derechos, which are going to be that wind-driven portion of it, as well as quasi-linear convective systems. That's a lot to say. We like to just simplify and call it QLCSs. This is your tornado risk. This is when you could see that embedded rain-wrapped tornado going along with this squall line. Then we also do have bow echoes as well. And as you can see in that video playing right now, right over Grand Forks, you get that wind report right there itself. So that is that storm report coming into our office of wind kind of coming through. And as you can see, it kind of bows out in nature as it's passing through the entire area. That's that wind. That's that downward push of that downdraft as it's pushing all the way out into northwestern Minnesota. Now, another one is supercells. Here's the other side of it. So here is a great image. So we're taking the supercell, we're cutting it right in half. As you can see here, here's that cumulonimbus cloud. It's bubbling up. It's pushing that updraft all the way up, and you're getting that cloud brace, striations, and wall cloud at the base, and all the way at the top, you get that anvil. That's when the air itself can't cool, and it's cooling as it rises, but then it starts to warm in the atmosphere at that very top, so it kind of can't go above that. So it's going to push outward. As it does, it creates that nice crisp anvil shape. And once in a while, you'll get overshooting. That storm is so strong and that updraft is very much there that it's going to push those clouds above, and you get more cauliflower kind of top on that. And then you kind of get that anvil back shear on the other side as it kind of keeps pushing outward. Now on the other side, you're going to get that shelf cloud. You're going to get that push of downdraft where that hail can't sit up there anymore. It's got to come rushing down with all that rain as well because, like we said before, gravity always wins. Just look at me in the wintertime. I always fall. Gravity always wins. And on the backside of these thunderstorms as well, you do get mammatus clouds. They are that underside. You're going to get a gorgeous view of this with the sunset sometimes in the background, and it's going to be that fluffiness on the backside of that. And then in that updraft region, like I said before, you're going to get a wall cloud and a precipitation-free base because we're taking all that air at the base and we're rushing it up in the updraft itself. You're going to get a kind of flanking line, we call it. That's where that air is rushing into that storm itself, and it's starting to go up. It's starting to cool. It's starting to coalesce, and we are going to get that rain. You're going to get that hail forming in that area. So here is a great view of our supercell thunderstorm. This is actually up in Bottonow, North Dakota. See those strong striations in there? See it over time like that? That is an indication of a strong supercell. It almost kind of looks like an alien spaceship kind of rolling through the area when you're seeing it in the distance, like a sci-fi movie.
Right. So that's those striations are because the whole thing is spinning. Like so the wind shear is creating an environment where the updraft is spinning like a top. And so those striations are because you're corkscrewing the updraft up into the atmosphere. And so those striations are really a sign of the rotation of the updraft and of the clouds as they spin counterclockwise up into the sky. And we'll play it until the end so I can switch to the next slide. Go. All right, so those are the supercells. Multicells are much weaker, and the atmosphere doesn't really know what it wants to do. So it's starting to pop a updraft or a shower here, and right next to it might pop another one, and next to it might pop another one. But there is no consistency. There's not enough shear to really keep things organized into one place to pull everything together to get the get one storm to just have an updraft and continue. It's much more popcorn like. It's much more random, and so we have a video of what that would look like here. So we see this. We have an updraft here, and then it kind of fades. Now we're gonna have one back here, and another one back here. Now we have one here, and one back here, and they just kind of keep going in different areas where it's not one consistent pocket of organized lift. It's much more isolated and temporary and brief. You know, the severe threat with these types of storms are not consistent, and so on radar we're watching a cell go up, and then it has a good core, and then all of a sudden it's done. And there's no core, and it pushes out wind. And sometimes that wind is really close to the threshold of severe weather, so you might get a pocket of 60 reported at one spot and see something else develop exactly the same way, and then it collapses, and that pocket of wind is only 40 at the next spot. So it can be kind of frustrating to try to keep track of where the worst of the severe weather threat is for a multi-cell.
Yep, so now we're going to kind of transition to talking about those updrafts and those downdrafts. So where they meet, that interface area, that's a good area to kind of watch for when you're observing. This interaction, it's crucial for the development and the strength, longevity, and severity of this thunderstorm that does develop. And you can see right here, that rain-free base on the left-hand side, that updraft region, that's going to propel all that moisture up into the air. You're going to get your wall cloud development in this region. And then that haziness kind of feature that you see on the right-hand side, it kind of blends the sky together. That's that downdraft region. That's your hail. That's going to be your wind area, as well as that's going to be your heavy rainfall as well. So in this video itself, it kind of gives a good image of what it looks like. So on the left-hand side, you see that updraft region, no rain.
Has two
and then on the right-hand side, you
anatomy.
kind of see that downdraft region.
Is the
it's kind of
updraft
blending
of
the
the
sky
storm.
together. The storm
This
right
is
now
where
is
air
kind of
rises
still
through the
developing, but you
atmosphere.
can see
An
the
updraft
rain kind of
begins
start to
with
fall
air
out of that
lifted
storm.
from the surface or just above the surface. As the air is forcefully
And like
lifted,
over here
what
as
you
well with
often
this
hear called
image,
forcing,
there's that
air
downdraft
will
region.
condense and
You can kind of
organize
see
into
that
an updraft.
blending of the sky
As
and the
the rising
cloud
air
like that.
condenses
That's
higher
all your
up in the
rain falling
atmosphere,
out. That's
and
your
water
hail
droplets
mixing in
become
there
bigger
too.
and bigger.
And the other
We'll see
hand, you get that
precipitation
updraft region.
in
So
the
this
second main
image
part
right
of the
here,
storm,
that's a
called the
chaser kind of
downdraft.
going through that downdraft region
is
where
where
that heavy
rain
rainfall
and hail
is,
will fall
and where
out of
that
the
hail
storm's
can potentially
updraft
be.
towards the ground. Think of it this way: an updraft is when
So some strong visual cues when you're looking at a thunderstorm in the distance. So you want to see those sharp, crisp cloud edges. You want to see that structure to it. You actually want to see upward motion. If you can stare at it long enough, you can actually see the clouds start bubbling up and go higher up into the sky, developing that anvil at the top. You want to look for visible rotation in the storm. You actually can start to see those striations where the wall cloud is and see it turning. And then also look for that momentum. It is beautiful. It's cool to see. But that is a great indication of that strong feature in that thunderstorm itself. And some weak visual cues. So we're recording this on April 22nd. Looking outside, we have just those stratus clouds that are kind of lingering across. It's very fuzzy. That's a good indication of some weak cloud. We're going to get a weak visual cues, I should say. So it's fuzzy cloud edges, weak upward motion, ill-defined storm structure, really no visible rotation with the storm. Like I said, outside today on the 22nd of April, we just get some rain showers going through the area. That's weak visual cues with that. No visible rotation, no real storm structure to it, just fuzzy clouds and some rain showers moving through. So we're going to separate these different features that you can kind of see of updrafts and downdrafts. So the rising section, the updraft region, which is on the left-hand side of that image, that's where we're going to get wall clouds, tail clouds, funnel clouds, scud clouds, as well as tornadoes. On the other region, where we're going to get that rain rushing out and we get that cooler air, we're going to look for shelf clouds, gustnadoes, scud clouds once again, and also microbursts.
Yeah, and I think it's important to say that they're sinking features, right? And so that's the motion of the air. The motion of the air is the sinking feature, so that shelf cloud is pushed out away from the storm as the cold pool air rushes out away with that downburst of hail or precip load, and the updraft is where that wall cloud would be forming and the tornado would be forming, those funnel clouds. So those are the key things you're looking for in the updraft or the rising region, right? And so wall clouds, they develop beneath that updraft. So this is the big push, the big lift, and the storm is right here. Right underneath that lift or push, the pressure's lower, and that helps allow that condensation cloud from the lower pressure occur. So since it's a lower pressure, the condensation occurs readily and closer to the ground, and that's spinning motion helps kind of carve or create the wall cloud right underneath where that strongest lift in the updraft is occurring. You're looking to see if there's upward motion in this wall cloud. You're looking to see if it's rotating. You're looking for the area of strongest rotation. The first indication of potential tornado development, maybe a little finger funnel cloud. It can be right in the middle of the wall cloud. It could be on the far edge. It doesn't really care where in the wall cloud it starts to form. It's not always going to be in the middle. Again, rain-free base near that flanking line. Over here is the rain and the hail. It's going to be hard to see anything, especially if you're like on the other side of the storm trying to look through. You're not going to see, especially when the storm is mature and that rain and hail has had a chance, to get developing and to start falling. Initially, when you have a strong updraft, you're not going to see yet any sort of rain and hail because it hasn't reached the top and gravity isn't pulling anything down. It hasn't won anything yet. So initially, you can see the whole thing is rain-free, but eventually you're going to have the rain and the hail as the storm matures.
Gravity will win.
So here's some wall cloud examples. Probably a cool or moisture-starved system here with a smaller, less well-defined wall cloud, but definitely a wall cloud, and then a little much more defined, right? Like that base is kind of stout and well-defined, sharp edge, really close to the ground. And if this was a video, it's probably you could see that merry-go-round really spinning. So let's play these two videos side by side, and I think you'll be able to tell the difference in rotating versus non-rotating relatively quickly. Right, the shape is fairly similar on both wall clouds. Most wall clouds will have that point down to the right a little bit, and then kind of a slantward back up to the left. But the one on the right is just kind of hover, and you don't see any motion. It's just kind of stagnant and staying there. But the one on the left is really cranking away, and that rotation in and of itself on the left side really screams like this storm is really spinning and getting itself together, kind of organized. Whereas on the right, there is some rotation here. We've sped it up much faster now, but this wall cloud isn't moving, right? There's just no rotation here, whereas the one on the left, it was very obvious.
So some features with updrafts are scud clouds. It's taking a parcel of air, it's creating that cloud, bringing it up into the base of the thunderstorm. They're on the leading edge of cooler and or moisture air It can be in the updraft region, but as well as the downdraft region. See kind of on that video how it quickly rises up and goes up? That can be confused for a funnel cloud. That's why we always sit there and we kind of look at it and go, okay, is it rotating? That's the key with it. They're just visually going upward into the base of the cloud, but they're actually not rotating. So that's why you always sit there, observe for a minute and take a look and see, okay, is it turning? Is it moving? That can be why people can mistake these for those funnel clouds or tornadoes, especially if you're far away in the distance. So when it starts rotating, when we actually get some rotation in there, as you can see in this video right here, that's when we get the funnel cloud. They're narrow, very vertical, tube-like cloud features, and they'll be tied to the wall cloud itself. It will be rotating, like I said. They're going to be kind of smooth in appearance, but watch that storm, watch that funnel cloud, observe for a second, and then take your eye and immediately go right toward the ground. Because once we start to see that contact with the ground, it's no longer just a funnel cloud, it is a tornado on the ground. So you want to look for that swirling dust at the base to see if there's any debris being picked up. So when we start to see that funnel cloud develop, take your eye, like I said, and bring it right to the ground, because not all the time will you see that connection fully from the cloud to the ground. There could be some really nothing in between, but you'll see that dust and debris at the base, and then you'll see the funnel cloud at the top. So that is still a tornado itself. You just won't see that full connection like that. So it's always good to take a second and look for that connection to the ground.
It certainly is a
And then
shape or a funnel shape.
The other updraft feature, tornadoes. So it's that rapidly rotating column of air, and it's in contact with the ground. So this storm is very visually appealing and everything, but look at how it's very of a drill into the ground. No precipitation around it itself. This is the Ashby-Dalton tornado that did occur in our county warning area. So this occurred in that Grant County through that Ottawa County area. This storm, very picturesque as you're seeing it. But you can kind of see right there that drill bit right into the ground. So it's not affecting a large area in this video. However, that farmstead that you see in that image right across the street, that's on the ground. It's affecting that crop field right over there. It's picking up that dirt, that those crops, everything, and swirling that up into that tornado itself. And there's a really good visual view of that right there. So the spatial scale is something that we like to talk about when it comes to tornadoes, because the storm itself might be very massive, but that tornado is affecting that small, finite area like that. So those people, hope they were in their basement for this tornado. It's right across the street. You can see it drilling right into the ground. And then with tornadoes, in those QLCS events, we get them rain wrapped. These are very deadly. It is basically like an overnight tornado, a nocturnal event. It's difficult to see in these situations.
Ben, tell me, do you
so
have
you
an
cannot
update?
see
I got
anything
42.
around you.
Where is the rotation?
As you can see on the
We're
left-hand
in the
side,
rotation.
in that reflectivity on the left, and then that is velocity on the right. You
No,
can
we're
see
in the tornado. We're in the tornado.
That wind
Our ears
direction
are
is
popping.
shifting like that, but it's
Our ears are
in that
popping. The
higher
tornado is
reflectivity.
right over us
So
right
basically,
now.
when these are occurring, it is not safe at all when it comes to observing these, because you can't see it.
Over us.
It's like being in the nighttime walking around, you can't see
in the
anything.
tornado.
So
in
these
the
are
tornado.
very dangerous situations. As you can see in that video, that storm itself, they are putting themselves at risk in this situation.
Right now, our car is about to tip over.
Heard in their car.
It's going by us. It's going by us.
I don't know if you can hear me with these high winds.
It's going by us.
100-mile-an-hour winds rocking our car right now. There's tree limbs down everywhere.
It's going by us. It's going by us.
It's in a fog. It's in the monsoon of rain.
Oh my God, we just went through a tornado.
I cannot believe that.
We just went through a tornado. Oh,
Downdraft
dude.
feature, shelf clouds. These are
Ben,
those,
tell me, do you have a...
most occurring across the northern plains. You know, tornadoes get the most publicity. They're the movie stars, but the downdrafts and the shelf clouds are what do most of the damaging work when it comes to what we deal with across the northern plains, right? It's that 60 to 70 to 80 mile an hour push of wind associated with the squall line gust, the gust front along that squall line, or the QLCS. Strong winds immediately come as that cloud or that shelf passes, and it's from on the horizon you can see it approaching, and it stretches from as far you can see to the south and to the north. Very common occurrence. Occasionally they have a little bit of a little impingement on them, right? They're not perfectly linear. They may have a little kink in the line a little bit that has a slight rotation, that has some horizontal, if not vertical, rotation that can occur. The wall cloud versus the shelf cloud, right? The wall cloud, we've mentioned this already, that's the updraft, it's the inflow, vertical rotation, associated with the tornadoes, associated with supercells, whereas the shelf cloud is that downdraft, that outflow, horizontal rotation, moves along the outflow, along the leading edge of the cold air in the precipitation area, associated with damaging winds, squall lines, multi-cell storms can have the shelf clouds. So how do we, examples of some spotting as we're moving on to 50 minutes now. So if you're still with us, thank you. Here's some examples of spotting, right? So this is the downburst of wind and why and how that thunderstorm produces that severe wind push to the ground. So we use the imagery from the desert Southwest just because we get to see more of it happen.
Photographer and monsoon chaser Brian Snyder was taking time-lapse footage of a storm in the Tucson area when he captured this incredible weather event.
Very high bases,
wet
right? There's a lot of
microburst.
air between the ground and the cloud level because the dew points are so low or the temperature spread is so high.
Microbursts affect
And so
an
this
area of no
allows
more
us
than
to
2.5
see
miles
this
across,
downburst of wind on
and they
this
occur
video
when a
clip.
cooled,
And
heavier
then you
column
can
of
see when
air
it
sinks
hits the
rapidly in the
ground,
middle of a
how
thunderstorm.
that wind has to go out
As the air hits the
away
ground,
from
it spreads out
to
with
where
great
that
force,
downburst
often
occurs.
generating winds of over 150 miles
So
per
you can
hour.
see that precipitation, cold
In the case
air
of a wet
is
microburst,
heavier
it also
than
brings crashing
warm
rain,
air, so you can see it
often described
falling
as a
out of the
rainbow.
sky. Gravity can't hold it anymore.
Thunderstorms
the
are
updraft
frequent
can't
and quickly
compete with
forming at this
gravity
time of
anymore
year in
and pulls it
Arizona,
down and
but to
then
capture a
push-
microburst so
pushes
vividly
out
was a
away from
special
the storm.
event.
So that microburst hits the ground and it causes much more wind damage to occur that way. So when you're spotting, we're wanting you to ask yourself these questions. Is the feature rotating? Is that rotation column connected to the cloud? Is there dust or debris observed on the ground underneath that feature that's rotating? As you can see in the video here, behind the outbuilding, we don't know if the circulation is on the ground or not, and then we have to wait to see if it is, and there's a little bit of dust there at the bottom of the screen between the doorway and the right building there. Play it again. Realize that this feature may or not be fully present between the cloud base and the ground. This funnel cloud feature may be here, not here in the middle, but that circulation is right on the ground and it's dancing across. And so we have a tornado. We don't have just a funnel cloud, there's a tornado. And now it's behind this outbuilding. This funnel cloud isn't all the way on the ground, but we can see that there's rotation associated with this. We're just wondering, is it connected to the ground? So that's what you're watching when you're asking yourself these questions.
So this is a photo that I actually took because back in the day, I did do some storm chasing when I was back in college, and I took this actually in western Kansas. So if, Jim, you want to click one more, that little feature right there. If I'm looking in the distance, it can look like, oh, potentially a little funnel cloud or something like that. This storm right now, you're looking at the updraft on the left-hand side, and you're looking at the downdraft on the right. So right in that box right there, that's a scud cloud. So that cloud itself, if I were to play this in motion as I was sitting there on this rural road, I could see it just go slowly up into the cloud. It didn't rotate, it didn't do anything. Now the storm itself did produce a tornado later on, about 30 to 45 minutes as we were chasing. I got to experience the downdraft, the updraft of the system itself, and also the numerous dents into the vehicle and the broken windshield that we had to drive from Kansas back to Wisconsin with. So safety is utmost importance to a lot of things. Now, tornadoes over water, they're water spouts. As you can see here, this is a column of air rotating rapidly and is in contact with the water surface itself. We have multiple lakes across the area. We have Lake Bemidji, we have the Upper Red Lake, Lower Red Lake, Lake of the Woods,
Devil's Lake.
They're all over. So with these, when the tornado is on the surface of the water and you're on a boat and you see this in the distance, get to the shoreline immediately. Sometimes on the upper of the Great Lakes itself, special marine warnings will be issued down the Gulf Coast as well, or the Atlantic or West Coast of the United States. Special marine warnings will have those indicators of potential for water spouts to occur, and that's when you want to get to the shore and get away from harm.
Yep.
So some lookalikes that we can see with this. Scary looking clouds. Those are those scud clouds. It's that low lying cloud. No rotation with it. It's just slowly sitting there and gets sucked right up into the cloud itself. Blowing dust from a distance. Rain shafts can look like that. And, people confuse it. I've done it before in the past. Smokestacks, silos, and any kind of tall structure. There are some hills in North Dakota, in the eastern part of our state, and also in northwestern Minnesota. So if you see a smokestack in the distance, it connects to the cloud randomly, it can look like a tornado. I get it. I've done it before. But that's why we watch for rotation, and we want to see that actual visual sign from that, those strong cues. So some classic hoaxes that you can see. So these are real storms. These have happened. These are those strong thunderstorms and those strong supercells. Now, let's put the Statue of Liberty in front of it. You'll see this circulate all over social media. Put the Eiffel Tower. We'll put the monument in Grand Forks to the flood here. We'll put that on the structure or anything like that. So
is that what you do on your free time?
Yeah.
Yeah.
Just take my time, make some fake images like this. That's what I do. Now I just eat Taco Bell. So with these structures, people could put the Taco Bell sign in the front of this. You never know. So these are classic hoaxes to kind of look out for. They're real storms, but people like to have fun with Photoshop and just put in different locations. So watch out for these. They're not real. Storm was, but they are not in a real location like this.
Reporting. So we're finally at the important part, right?
Yeah.
Right?
We're finally there. We're finally at that point.
All right, the do's and don'ts reporting. Please tell us who you are. Please tell us where you're seeing what is ever that you're seeing that is occurring. And then when did it start and when did it end? Watch the storm for a few minutes. Report exactly what you see. Just tell us where you're looking, what you're seeing. Express the uncertainty. It's okay if you're unsure. We want the report. How do you get a hold of us? This is our phone number is 1-800-667-1218. You can use social media. You can use the MPing app, which is great if you're going to be moving around and you take that quick picture of something or just send in a report on the MPing app. You don't have to know if you're 8 southwest or 4 northeast of whatever. You can just use MPing and it plots as tagged your location. So it plots on our PC radar imagery where that report is from.
And it pops up immediately on our
Yep.
workstations.
Yep, it's not something we have to go look for and then throw on that later in time. It's immediate into our workstation. Additional sources, your local spotter group, local ham radio net, spotternetwork.org. If you got pics and you want to send, we have an email address. That's not the best thing to use in real time, but after the report or after the storm, we have an email. You can send us that way, that information, or you could send it to us on social media. Like I said, download the MPing app. Here it is on the App Store or Google Play Store. It's a cooperative project from the University of Oklahoma, NOAA, and NASA to get real weather information. It doesn't have to be just summer information. It can be winter. It can be snow. It can be mudslides. It can be fog. It can be anything and everything weather related.
Freezing rain reports with this is
Freezing
very,
drizzle, freezing
very
rain.
good.
Yeah, that's helpful. The radar overshoots that terribly. So when it comes to the size of a hail stone, what do you report? Find the stone and measure it. Provide the location that this hail occurred, how long it lasted. If you're in your truck, have your coins and or a few, a golf ball, a baseball, a tennis ball, those different types of things to compare the hailstone to, and then you can use that comparison to report an accurate measurement. Maybe you have a tape measure, right? Like in your truck, who knows, right? So we really are interested in hail that's an inch or larger. That will verify any severe weather warning that we issued. But we're still interested in those pennies and those nickels. Even the small half-inch, it kind of gives us a key that, okay, this storm is already producing half-inch size hail. Like that gives us an idea of the threshold that maybe need for severe.
And try to stay away from comparing it to some like fruits, like an large apple, because they come in a variety of sizes. I'm going to sit there and I'm going to ask on the phone or through different things, say, what kind of apple is it? Red Delicious? Is it a lime? Something like that. So try to find a monetary thing, golf ball, ping pong, anything like that. Our tape measure is the best.
Yeah. When it comes to wind speed and damage, I think I mentioned this earlier, any sort of damage to structures, to power lines and power poles, trees snapped and uprooted, tree limbs 3 inches in diameter, so about the size of your wrist, are all indications of severe wind damage. Crop damage, boats flipped over. We know that most of our reports are going to be based on wind damage. So those reports are kind of essential, crucial. We like to get those reports. We appreciate those reports. When it comes to flooding, flash flooding, after the fact, even and or during the fact, we like to know when the culvert gets ripped out from the flood, or if there are any structural issues. Are there any local rivers or streams out of their banks, road closures on those county roads that are susceptible? Is it flowing water or is it ponding? That information helps us immensely when we're trying to figure out those impacts.
So in this situation, Jim, what do you report? Look at it carefully.
It's a obviously we got funnel cloud, but then that funnel breaks all apart and I don't see it reaching all the way to the ground, but it does look like there is some gray haze, dust, maybe water spray from recent rains down here at the bottom. So I think Amanda Elms and myself would report tornado here.
Exactly. So That's why you always look at the top and then drag your eye right to the bottom and look to see if there's any kind of debris kind of coming up, crops or anything coming up, because that would indicate that tornado itself.
Right there, yep.
So here's a great image as well when it comes to reporting hail size. So you can see the ruler laid right out, multiple hailstones. So not just 1, 2, or 3, got multiple. They probably did this after the fact. Do not go outside while it's hailing and start picking up hailstones. After the fact, you can grab some and kind of compare it in an image with a ruler itself.
Yeah, some of these hailstones with the spikes, that would not feel good.
Yeah, I don't feel like
I don't think I would go out and pick one of those up while they're falling out of the sky.
that would probably be a trip to the ER at that point.
Right. 3 inches though looks like it's the biggest one. Right around 3
Yeah,
inches.
that's a big hailstone.
That's not something we want to have a lot of. How about here, Jacob? What do you report?
So in the distance, I see a funnel, but I drag my eye to the base. I'm kind of looking to see if there's any kind of debris kind of, and I don't. And I'm expressing that uncertainty. I really don't see that. But I'm gonna say that's a funnel cloud. And if I was playing this in real time with a video, I'd probably see some rotation with that.
Yeah, I would think so too. It looks a pretty sure thing that it's gonna, if it's not already on the ground, it will be soon.
Exactly.
All right, so where should we be when we're trying to spot these storms?
Yeah, so here is a good supercell thunderstorm that's actually near our area up in Grand Forks. This is just right by the radar itself. So we have 4 different locations in this one. Now, A, B, C, or D, where would I want to be to observe this storm? Now, supercells are very devious. They will deviate from their position, move slightly to the east, to the north, to the south kind of thing. So we always want to see and have that visual cue of where that thunderstorm or that tornado is itself and the way in motion this storm is going. So in this case, if you're in A, yeah, that thing's coming right for you. B, it can probably deviate towards your location and move to that south and east. Now, D, you're just sitting there. It's gone. It's out of the way. You're not even near it anymore. You're probably still seeing some lightning in the distance in that downdraft region, so you're really not getting any good visual cues. Now, C is the least dangerous. It is moving to your north. You're kind of sitting there on the side of the road, and you're just seeing it going right across the skyline in this image. So that is by far the best location for any kind of spotting when it comes to this supercell thunderstorm. And here are some good pictures of that as well. So A, you're looking at that tornado right there. Yeah, it's just getting larger. It's not moving side to side. It's getting larger and larger. It's coming right for you. B, you're seeing it in the distance, but that storm could deviate to your location, so it's still not safe. In C, it's moving right along the horizon. You're not really seeing it come closer. So that is the better scenario in this instance. And D, that's the downdraft. Yep. You're seeing all the hail fall out right there. You're seeing all the rain, the lightning, all of that. So it's the back edge of the storm right there.
So essentially, D, you're safe, but you're not really helpful.
Exactly.
Because you're not seeing anything.
But you could be some helpful if there was some hail that fell out. So
you could pick up some hailstones and... Yeah,
exactly.
Yeah. A, it's time to move. Get out. Right? You're too close. Have a safety route. Maybe 2 different road options, right? If the storm's moving due east, go south. Don't go north, right? There's nowhere to go. I wouldn't follow it too far east. You got a river that you have to worry about bridges for, right? So get south. If you're B, yeah, if this thing is going southeast, you're kind of in the line. But I like the fact that you're far enough away to really gauge where it's going and how it's moving, and you can stay mobile and either go south, go north, back to the west if need be to get on 29, and then go like. You seem to have some options with B, and like you said, C, you're safe, right? Like there's very few of our thunderstorms go north to south, although it can happen. But like you've positioned yourself, and just keep going east with this thing as it goes east, and you're going to be able to watch whatever it does as long as you got an east road. So
Always have a plan if
Yep.
you're out there. Just know what roads you have. Don't go down dead ends, no outlets, anything like that. That puts you at harm's way.
and storm spotting during squall lines, that's kind of difficult too. But at the same time, where is the tornado threat here, right? Like a squall line, you're going to see wind, but every once in a while, these squall lines can spin up tornadoes on the leading edge. And so D, we're past that squall line. It's already here, and we don't have to worry too much about D. It's just the rain and the wind is done. Rain is ending slowly. A, you're not really in that warm sector of air that's feeding the squall line. You're probably along this pseudo stratiform or area of precip that's much more elevated in nature. You're not going to have any sort of connection to the ground per se that a tornado could happen. So A and D seem pretty much, no worries or concerns with any sort of tornadic activity. But what do you think about B and C?
Yeah, so for B and C, it's gonna happen. It's gonna come right for you. So you kind of really are gonna experience that damaging wind, and especially with that kind of push on that one toward B, that's where you could potentially get that stronger wind. And you can see down in Steele County, or Steele, the city itself in Kidder County, you see that's a report of 60 and 80. That's some strong wind. That's gonna take down some trees. So that's when you kind of take some shelter in that kind of instance. And you kind of want to, when we kind of look for these thunderstorms, we look for that QLCS development. We look for that leading edge of that to see, could it spin up a quick tornado right on the leading edge of that and produce even more damage itself. So some spotter safety itself. Safety is just the utmost importance in any kind of situation. So be situationally aware. Know the storm motion. Know, are you at a safe distance away from it? Are there any other storms in the area, or is that the only one? And then, are you safe from lightning, from hail, from flooding itself? Do you have an escape route? Like I said before, don't go down any no outlets if you're in that area. Don't go down any areas that have road closures, anything like that. Know your place of shelter as well. So always have a way in and a way out itself. And visibility, anytime around storms, especially in rain-wrapped tornadoes or in nighttime, visibility is reduced. So be very cautious and everything like that, and just be very safe. It is the utmost importance. So another thing, if you're in a vehicle, do you want to go under an overpass or underneath a bridge, Joe?
No, I don't think that's a pretty good idea. There's lots of reasons for it, but you're actually moving into a wind tunnel where the winds will be stronger through that area than if you were out in the open. If you move in or park under a bridge of some sort, you're all of a sudden going to be blocking any sort of other traffic, or in a lower spot in elevation also. So avoid putting your vehicles under bridges, overpasses, or any sort of location like that.
So for some lightning, we always say it, when thunder roars, go indoors.
Yeah,
I had to say it like that.
That was wonderful. If you hear thunder, you're at risk for lightning. It's by far the most common hazard facing spotters, right? Because we're asking them to go out and tell us what the weather is when we know there's thunderstorms occurring, right? So be careful on hilltops and open areas, out on the lakes where you're the largest body of water, or largest body, tallest body, out on an open lake. Stay in your vehicle if you're mobile. Roll those windows up. Your tires will protect you, right? The tires don't protect you, but the frame does. Keeps you safe. So if your vehicle does get struck by lightning, you should be okay.
So some for wind safety, these, like we said before, are frequent with the squall lines. They can occur in any type of storm itself. So in this video right here, you see the wind is slowly picking up, and then it really starts to go. The power kind of goes up too. You see those tree branches start to kind of go down immediately. So it's going to be in that leading edge in that downdraft region on that shelf cloud. Really good indication of some strong winds. So don't seek shelter underneath any trees. They will collapse and that puts you at risk. So don't go any small structures. They might collapse well. Get inside. Get in a stormy area. And then in our next one, hail safety. Hail can fall very fast, and it can be very dangerous. Small hail can cause damage and injury as well. It can pile up to 3 inches on the ground, penny-sized hail. That can still cause damage. As you can see in these photos right here, the window's breaking. You see that large hail, and then you see welts. This is why we don't say like go outside during hail events. You stay inside. Do not go out until the hail is done. Because if you're running out there with pots and pans trying to catch it, is that a good idea, Jim?
No.
Exactly.
No, that would hurt.
So with flood safety as well, here's a good video of this. You see the ring, it's coming down and everything. Look for kind of signs with this. Sometimes it kind of blends into the road. So you see the water splashing up, and then you see a cop car. It is the #1 weather-related killer in the United States. There's that cop car right there, and then you start to see the water on the road, and it's too late. This car gets submerged right away, dragged right into a river itself. So heavy rain combined on those saturated soils, or heavy rain in more of a metro area like Fargo or Grand Forks, it can start piling up quickly on that concrete, because concrete and asphalt, it's not going to be able to absorb the water, so it's going to pool there. So like I said, in those poor drainage areas and the amplified by terrain area, that's going to increase that risk. And remember, turn around, don't drown. We say it every single year, and we'll every single time say it. Turn around, don't drown.
It's not worth the risk. But the risk isn't worth the reward of saving a little bit of time when you're uncertain about how much water is over the road and the water's moving. Do you really know how deep that water is? 12 inches of fast moving water can carry away your small car. 18 inches can move your SUV, your truck, whatever. If you're in doubt, if there is any inkling, I know that we have a lot of flat areas and there's often water in the spring, but summer rains are way different than snow melt. So summer rains, when we get 7 inches or 8 inches overnight, we can wash away a culvert, we can wash away a county road, a ditch or whatever that maybe was a low spot that normally has water on in the spring. We don't know if it's been washed away if you've gotten 10 inches of rain overnight. And maybe you didn't get it and it happened 10, 15 miles away, and now that creek is pretty high and it's been running all night and it's washed out that culvert that you typically drive over. So just take a minute, stop, think, turn around, add 10 minutes to your trip, find a different way over the water. And finally, tornado safety when you're at home. Lowest level, interior room. Stay away from windows, not on the top floor of your house. The roof and the exterior walls are usually the first things that go in a tornado, or the tornado is carrying debris and it throws that into the windows and they shatter. So interior walls, lowest level of your home.
And if you don't own a home and you're in a mobile park situation, find a tornado shelter area. They're designated in your community itself. So find those areas that will protect you. And if you don't have a basement itself either, you can find that lowest interior, take a mattress if you need to, put it over yourself, and get into a area that's enclosed, away from glass or anything like that. That interior part is crucial with that.
Yes. So, as a spotter, your safety is our #1 concern. We would ask you to keep an eye on the sky and prepare for all hazards. You're watching for lightning and flooding. You're using common sense, having an escape route when you are driving around and spotting, right? You want more than one way in and out of any area. You're not going to drive over flooded roadways. You're not going to go spotting at night by yourself. Like, use common sense. We appreciate the reports. We need the reports. And I hope everybody has a great summer.
Yeah, I do too. Thank you all for taking the time to tune in at home, anything like that. It's been a pleasure. So everyone, have a good rest of your day, and I'm probably going to go home and make myself some tacos after that taco watch warning.
All right. Appreciate it. Thank you, everyone.